All right, I'm trying something new, trying to put everything up on the board all at once so that you don't have to keep going back and forth between screens. Hopefully this will work. We'll find out. So this is from section 4.5. This is problem number 9. And we're going to start out with, let me make sure I've got the ink color is black. There we go. Okay. So we're going to graph this system of linear inequalities, and I'm going to graph it straight onto the WebAssign screen on the left there, and we'll see how this works out. So what I'm going to do first of all, I'm going to take the inequality 2x minus 3y less than 0, and I'm going to write the related equation 2x minus 3y equals 0. I'm going to make a table and find a couple of points. We'll start off and find the X-Intercept. So to find the X-Intercept, y equals 0. So we get 2x minus 3 times y equals 0. 2x equals 0. Divide both sides by 2. X equals 0. So that means that this equation that I'm looking at would go through the origin. Let's find another ordered pair. Let's let x equal 1. So then we have 2 times 1 minus 3y equals 0. 2 minus 3y equals 0. Subtract 2 from both sides. Negative 3y equals negative 2. Divide both sides by negative 3, y equals 2/3. Okay, now you might wonder, why didn't I go back and try and find the y-intercept? Well, the y-intercept would have been at 0, 0 as well. Okay, so now let's take the 2 points that we've got, and we've got that blue, we've got 0, 0, and 1, 2/3. Now, when I try to graph 1, 2/3, it didn't go onto 2/3, it moved up to 1, 1, so I'm going to come over here, and my first point is 0, 0. My second point should be 1, 2/3. Okay. Now, also, if I go back here and look, you see that the original inequality did not include an equal sign. So we need this to be dashed. All right. Now, let's pick a test point. 0, 0 is on the dotted line, so we can't use that as a test point. How about if we use, let's go with 4, 4, which would be up here. Okay. So back over here, let's see. If I take the point 4, 4 and put it into the actual inequality, I get 2 times 4 minus 3 times 4 less than 0. 8 minus 12 less than 0. Negative 4 less than 0. That's true. So over here, we're going to shade or fill in above. And back over here, I'm just going to put a little, I got to get my cursor back over there. Oops. I'm just going to put in this to remind me that it was above the line. Okay. So we'll say above. All right. Now I'm going to go back over here and change my ink color to red. And we're going to deal with the second half of the problem. I'm going to take a look at the related equation 2x plus 3y equals 11. And I'll go in and find the x-intercept by setting y equal to 0. So 2x plus 3 times 0 equals 11. 2x equals 11. Divide both sides by 2. X equals 11 halves. Okay. It's kind of hard to read that. Sorry about that. Here, let's do this. Let's get an eraser and see if we can clean that up just a little bit. Okay. Back over here, 11 halves. All right. Now, let's go ahead and find the x-intercept, excuse me, the y-intercept. So we'll set x equal to 0, which gives us 2 times 0 plus 3y equals 11. 3y equals 11. Divide by 3, y equals 11 thirds. Okay. So we've got our 2 points there. We've got 11 halves, 0. 11 halves would be 5.5. So 5.5 is 0. Oh, look there. It keeps going to the nearest integer, but I'll fix it here in a minute. And then 0, 11 thirds. 11 thirds is like 3 2/3. Okay. But I'm going to come over here. My first point is 11 halves. So 11, or my first coordinate, 11 halves, 0. And then 0, 11 thirds. Okay. Now, this second inequality includes equals, so it needs to be a solid line. Okay. And I'm going to go ahead and use 4, 4 again as a test point, because it looks like it should work there. So over here, we're going to put in the point 4, 4 and put it into this inequality. 2 times 4 plus 3 times 4 greater than or equal to 11. 8 plus 12 greater than or equal to 11. 20 is greater than or equal to 11. That's true. So 4, 4 over here would still be above. Okay. So now, if for the dotted line, it's above, and for the solid line, it's above, can you see that the intersection would be this area right there? Okay, so that takes care of problem number 9. We're going to go on to problem number 10. I'm going to clear that and scroll down here to problem number 10. And we want black, first of all. Okay, so here we go again. We're going to take the inequality 3x plus 2y minus 15 greater than or equal to 0. We're going to find 2 ordered pairs. Actually, first of all, we're going to look at the related equation. I always tend to forget that. Okay. Let's see. Let's find the x-intercept by setting y equal to 0. 3x plus 2 times 0 minus 15 equals 0. 3x minus 15 equals 0. Add 15 to both sides of the equation. 3x equals 15. X equals 5. Let's go ahead and find the y-intercept by setting x equal to 0. I had to think about that a minute. So we get 3 times 0 plus 2y minus 15 equals 0. 2y minus 15 equals 0. Add 15 to both sides. 2y equals 15. Divide by 2. Y equals 15 halves. Okay. Yeah, y equals 15 halves. All right. So let's go over here and let's plot those 2 points. 5, 0. 15 halves is 7.5, so I'm going to go right there, but again, it doesn't like it, so I'll come back here, 5, 0, and then 0, comma, 15 halves. Okay, and this first inequality includes the original, this one up here, well, yeah, includes equals, so it's a solid line. Let's use 0, 0 as a test point. Okay, oops. All right, so we'll put 0, 0 in up there into this thing. So we're going to get, tell you what, I'm going to write it down here in the lower corner. I'm going to get 3 times 0 plus 2 times 0 minus 15 greater than or equal to 0, negative 15 greater than or equal to 0. That's not true. So 0, 0 is not in the solution area. So it's got to be on the other side. So I'm going to fill there. And so I'm going to say, sorry about that. I'm going to say that it's above. Okay, our test point failed, so we picked the other side of the line. All right, let's go back and let's do the red inequality. And over here, again, we'll look at the related equation, x equals -1 plus y. We'll find the x-intercept and then the y-intercept. To find the x-intercept, set y equal to 0, x equals -1 plus 0, x equals -1. To find the y-intercept, set x equal to 0, 0 equals -1 plus y, add 1 to both sides, y equals 1. So let's take those 2 points and plot them, -1, 0, and 0, 1. Okay, -1, 0, 0, 1. This line is going to be dashed because the original inequality statement does not include equals. So go over here and make it dashed. Okay. Now let's see. For the solid line, the fill was above, wasn't it? Let's see about the dashed line though. Okay. I can use 0, 0 for that one as well. Okay. So let's see here. I'm going to put in 0, 0. That's going to, and I'm going to put that into the original inequality. 0 less than -1 plus 0, 0 less than -1. That's not true. Not true. So 0, 0 is not a solution to the dashed line, which means we're going to be on the other side, so up there. So that's going to be above as well. Okay. But I've got, so the dot, let's go back and get rid of these. The solid line above that would be these two. The dotted line above it would be those two. So the intersection would be this single piece up there. All righty. So let's clear that out and go to problem number 11 and get our ink back to black. We're going to take a look at x plus y greater than 0, but we'll consider its related equation. If y is 0, x plus 0 equals 0, x equals 0. So this goes through the origin. So we'll have to pick some point other than an x or y-intercept. How about if x is 1? If x is 1, 1 plus y equals 0. Subtract 1 from both sides. Y equals -1. So now I've got two ordered pairs, 0, 0, and 1, -1. 0, 0, 1, -1. This inequality does not have the equal sign as part of it. So I need to make it dashed. All right. And again, I can't use 0, 0 as a test point because it goes through the origin. Tell you what, let's use 4, 4 again. So 4, 4, we get 4 plus 4 greater than 0, 8 greater than 0. That's true. So 4, 4 is above. So I'm going to say above. And the fill would be this. Okay. All right, let's go back here and do the red inequality. So we'll look at the related equation. Excuse me. And we'll find the x-intercept. So I get 0 minus x equals -2, negative x equals -2, divide both sides by -1, x equals 2. And let's let x equal 0 to find the y-intercept. Y minus 0 equals -2, y equals -2. Okay. So let's plot those 2 points on the next grid. 2, 0, and 0, -2. 2, 0, 0, -2. This one also does not include an equal as part of the original inequality. So it also needs to be dashed. Okay. Now, let's see. I'm going to go ahead and use 4, 4 again. I'm going to move my cursor over here. Oops, sorry, keeps doing that. So we'll put 4, 4 into the original inequality. 4 minus 4 less than -2, 0 less than -2, no. So for that second inequality, which is, let's see, I wish we had more than one color on the WebAssign stuff, but the second inequality, which is this line, dotted line or dashed line here, 4, 4 is not a solution. So we're going to be below it. Okay. So let's go over here and we'll say below. All right. So now this first inequality, which was this one, it was above it, so it was here and here. The second inequality, which was this one, it was below it, so it was here and here. So where do the two overlap? Right there. Something I didn't do in the previous problems, but that we could do. Now that we think this is the solution, let's pick a point in here and make sure it fits both inequalities. How about 7, 0? Let's take the point 7, 0. Let's do this one in green. Okay. And if I take the point 7, 0, does it work in here and in there? Let's see. The first one, x plus y greater than or equal to 0, 7 greater than 0, check. The second one, 0 minus 7 less than -2, -7 less than -2, check. Okay, so at least I know that that region is correct. All right, we've got one more to go. So let's clear this and go back here to black ink. We're going to take y plus 2x less than or equal to 0 and look at its related equation. Y plus 2x equals 0. And let's see here. We'll set y equal to 0 to find the x-intercept. So 0 plus 2x equals 0. 2x equals 0. Divide both sides by 2. X equals 0. So again, this graph goes through the origin. How about if we let x equal 1? So we get y plus 2 times 1 equals 0. Y plus 2 equals 0. Subtract 2 from both sides, y equals -2. And now we'll come over here. And we've got 0, 0, and 1, -2. 0, 0, 1, -2. Okay. Oh, this includes the equals, so I want a solid line. Tell you what, I had good luck with 4, 4 before. So let's use the point 4, 4 as a test point. We're going to put that in here. 4 plus 2 times 4 less than or equal to 0. 4 plus 8 less than or equal to 0. 12 less than or equal to 0. That's not true. So 4, 4 is not a solution, so we want to be below. So below the line. So filling it would be here. Okay. Now let's go back and do the red inequality. Look at the related equation, y equals 1/2 x plus 2. Okay. Tell you what, since the coefficient of x is 1/2, if I choose x values that are multiples of 2, I'll get nice y values. So let's start with x is 0. So then we're going to get y equals 1/2 times 0 plus 2, which is 0 plus 2, which is 2. And then let's let x equal 2. So then y equals 1/2 times 2 plus 2. 1/2 times 2 reduces down to 1, and 1 plus 2 is 3. Okay. So our second line, we're going to have 0, 2, and 2, 3. 0, 2, and 2, 3. Okay. And that is also solid because it includes equals. Let's see, can we use 4, 4 again? No, we can't, because 4, 4 is on the line, isn't it? How about if we use, how about 8, 2? We'll use 8, comma 2. Okay. All right, where did my mouse go? There it is. So 8, 2. Putting it in there, we get 2 less than or equal to 1/2 times 8 plus 2. 2 less than or equal to 4 plus 2. 2 is less than or equal to 6. That's true. So let's see, 8, 2 is over here. So that's what? Below that second line. So okay, so back over here with a fill, let's double check this. This first one, 0, 0, 1, negative 2 was this one, and it was below it. So that would be here or here. Okay, or here and here for the first one. Then the second one, which was this line, it was also below that. So that would be here and here. So they would intersect down there. Let's go ahead and pick a point from there and check it. Let's see, how about negative 2, negative 2? And let's do this in green again like we did before. Okay, what did I say, negative 2, negative 2? Yeah, negative 2, negative 2. Okay, so let's put this in there. We'd have negative 2 plus 2 times negative 2 less than or equal to 0. Negative 2 plus negative 4 less than or equal to 0. Negative 6 less than or equal to 0. That's true. Let's put it over here. We'd have negative 2 less than or equal to 1/2 times negative 2 plus 2. Negative 2 less than or equal to negative 1 plus 2. Negative 2 less than or equal to 1. That's true. So it checks. Okay. Well, that's all for this video. So I'm going to stop the recording and I will get this posted on YouTube.